From smart surveying to high-performance concrete, modern road construction blends precision machines, data, and innovation to build faster, stronger highways. Modern road construction is undergoing a remarkable transformation thanks to the introduction of advanced technologies and highly specialized machinery. From innovative concrete screeds to intelligent slipform pavers and efficient surface maintenance systems, these technologies are redefining how roads, highways, and infrastructure projects are built around the world. One of the standout innovations is the Lura Roller Screed system, widely regarded as one of the world's premier roller screed solutions. Developed by Lura Screed, this system is engineered to handle virtually any type of concrete pour, including extremely challenging applications. A striking example is its performance on a conical concrete pour for a grain silo, where the screed successfully operated on a 38-degree slope, spanning 58 feet across and rising 34 feet from bottom to top. Such demanding conditions would traditionally require heavy, cumbersome equipment and large crews, but the Lura Screed makes these complex jobs look easy. What sets the Lura Roller Screed apart is its lightweight yet rugged design, which is ideally balanced for smooth operation while remaining durable enough for harsh job site conditions. It is easy to operate, transport, and assemble, significantly reducing setup time and labor requirements. The most groundbreaking feature is its threaded axle system, the first of its kind in the world. This innovation allows multiple screed units to be coupled together, making the Lura Screed the only roller screed globally that can be extended in this way. As a result, contractors can achieve superior slab quality on a wide range of projects while minimizing physical strain and operational complexity. Another time-saving innovation is the 24-foot custom MoDOT drum flume shaping system, supplied by Curb Roller Manufacturing to Realm Construction, Inc. This system was pulled along by a cable trolley on both sides and powered by a hydroscreed. As the drum rotated, it brought the concrete cream and fat to the surface while pushing aggregate downward, ensuring proper consolidation without causing the sides to slump toward the bottom. This precise control over concrete behavior results in stronger, smoother surfaces and a significant reduction in rework. In large-scale paving operations, Gomaco GP240 slipform concrete pavers play a central role. Known for their versatility and maneuverability, these machines are used on highways, city streets, airport runways, bridge decks, and safety barrier walls. The GP2400 features a telescoping frame capable of paving up to 16 feet wide as standard and up to 24 feet wide with additional frame inserts. Available in both 2-track and 4-track configurations, the paver can be adapted to different job site conditions. The 2-track version offers minimal transport width, while the 4-track version provides enhanced steering control, especially in tight or complex layouts. A key advantage of the GP2400 is Gomaco's proprietary G+ control system, which offers self-diagnostics for grade and steering, multi-language support, and compatibility with modern 3D stringless guidance systems. This technology improves paving accuracy and reduces reliance on traditional string lines. Powered by a Caterpillar diesel engine, the paver delivers reliable performance, while its U-shaped, skid-resistant operator platform ensures excellent visibility, safety, and efficiency throughout the paving process. Material preparation is equally important. And this is where the Dragonscreed material spreader comes into play. Towed by a CAT 289C tracked wheel loader, the Dragonscreed is used to distribute and level crushed stone, gravel, or similar base materials. Its design allows it to create a flat, uniform surface quickly, preparing the roadbed for subsequent construction stages. Compared to manual leveling, this equipment saves a substantial amount of time and labor while delivering more consistent results. The CAT 289C provides the traction and power needed to move the grader smoothly across heavy materials, even on uneven terrain. Concrete paving operations are further supported by concrete mixer trucks, which continuously supply fresh material to the pavers. This coordinated workflow enables a modern, fast, and highly efficient road construction process, reducing downtime and ensuring consistent concrete quality along the entire paving width. Another major contributor to modern paving technology is Terex, particularly through its Bidwell line of automatic roller pavers. Unlike traditional slipform pavers, Terex Bidwell machines excel in applications such as bridges, elevated roadways, and complex surface geometries. Their adaptability allows them to handle curved, super-elevated, and tapered surfaces with ease, saving time while improving construction accuracy. The proprietary roto-vibe system effectively compacts the top concrete layer, approximately 6.9 centimeters thick, producing a dense, uniform, and high-quality surface finish. Terex pavers also feature a high level of automation, including automatic machine movement and cushioned automatic reversing. These functions increase productivity, reduce operator fatigue, and minimize the need for large crews, making them ideal for demanding infrastructure projects. Finally, modern road construction does not end with new pavement. Maintenance technologies are equally critical. Chip seal coating trucks are widely used to extend the lifespan of existing roads in a cost-effective manner. This process involves spraying a thin layer of liquid asphalt or hot asphalt emulsion onto the pavement, followed immediately by a layer of fine aggregate. Chip sealing protects the surface from water infiltration, improves skid resistance, and delays more expensive rehabilitation work. In conclusion, the latest road construction technologies demonstrate how innovation is reshaping infrastructure development. From advanced screed systems and intelligent pavers to efficient material spreaders and maintenance solutions, modern machinery enables faster construction, higher precision, reduced labor, and longer-lasting roads. These technologies represent the future of road building, delivering safer, stronger, and more sustainable transportation networks worldwide. The PowerCurber 7700 is a highly versatile slip-form concrete paver designed to handle both offset paving and large-scale roadway construction with outstanding efficiency. Proven successful on projects around the world, this machine offers contractors a flexible solution for building everything from traffic barriers to concrete pavements up to 6 meters wide. One of its key strengths is the multi-purpose design, featuring a hydraulic telescoping frame that allows quick conversion between centerline paving, offset paving, and zero-clearance applications. The 7700 is equipped with the advanced Slip Smart control system and can be integrated with wireless 3D or GPS guidance, delivering high precision without the need for string lines. Operational flexibility is further enhanced by a hydraulically folding and swiveling conveyor capable of feeding concrete from either side. 4 independent hydraulic crawler tracks with intelligent positioning ensure smooth movement and fast setup across different paving modes. This coordinated concrete paving line from Guntert and Zimmermann delivers high productivity and precision. At the core is the GMCO 850 SL Slipform paver, capable of paving highways and airfields up to 41 feet wide, with its innovative swing leg design allowing fast repositioning and excellent maneuverability on complex jobs. Supplying material is the MP550 material placer, featuring 4-wheel drive, advanced steering modes, and a wide hopper with a long hydraulic swing conveyor. Completing the process, the TC1500 texture cure machine applies surface texture and curing compounds, ensuring durable, high-quality concrete pavements. Guntert and Zimmermann presents a comprehensive lineup of slipform pavers and concrete paving equipment designed to meet the demands of modern road, highway, and airport construction. With decades of experience in concrete paving technology, G&Z focuses on versatility, precision, and productivity across all project scales. At the compact end of the range is the G&Z S600 multi-purpose slipform paver, a highly adaptable machine suitable for a wide variety of concrete paving applications. The S600 is engineered for excellent maneuverability and job site flexibility. Its advanced ACCUSTEER system ensures precise steering control, while 320-degree track rotation, 90-degree steering, and counter rotation allow the paver to reposition easily even in tight urban environments. A semi-automatic transport mode simplifies relocation between sites, reducing downtime. In addition, telescopic end sections allow the machine to quickly adapt to different paving widths and profiles, making the S600 an ideal solution for curbs, barriers, variable width slabs, and specialty concrete work. Stepping up in size and capacity, the G&Z 850 mid-size slipform paver is one of the most versatile machines in the G&Z portfolio. Designed for applications ranging from city streets to highways and airport pavements, the S850 combines power with agility. Its double telescopic tractor frame enables paving widths from 12 to 26 feet, extendable to 34 feet with optional JC pin-in extenders, and up to 41 feet using bolt-in frame extensions. Power is provided by a quiet and fuel-efficient Cat C 9.3B 6-cylinder diesel engine, delivering 415 horsepower, ensuring consistent performance under demanding conditions. Exceptional maneuverability is achieved through optional 90-degree steering and counter rotation, allowing the machine to rotate 360 degrees within its own width, a major advantage on complex paving sites. For large-scale infrastructure projects, G&Z offers the S1500 multi-lane slipform paver, the largest and most powerful paver in the company's lineup. The S1500 is engineered for wide, multi-lane highway and airport paving, where strict smoothness and productivity requirements must be met. It is capable of paving widths from 18 feet up to 52.5 feet with extensions. The machine features a robust, heavy-duty design and a telescopic tractor frame that provides stability and accuracy across wide pours. One standout feature is the industry's largest telescopic front walkway, which enhances operator access, safety, and efficiency during large paving operations. Complementing the Slipform pavers is the compact dowel bar inserter, CDBI, an innovative attachment used in modern slipform paving. Rather than being a standalone machine, the CDBI is a self-supporting module that integrates directly with the paver. Its function is to automatically insert steel dowel bars into freshly placed concrete after vibration and consolidation. These dowels play a critical role in load transfer between adjacent slabs, improving pavement durability and reducing long-term maintenance. By eliminating the need for pre-placed dowel baskets, the CDBI significantly increases paving speed and accuracy. In the concrete placement stage, the PS1200 concrete placer spreader provides efficient material distribution ahead of the slipform paver. Known for its precision and modular design, this machine can handle paving widths from 4 to 8 meters and up to 12 meters with optional extensions. A key advantage is its self-loading capability, allowing it to lower itself onto a flatbed truck without external lifting equipment, simplifying transport and logistics. Finally, the GMCO 1500 texture cure machine completes the paving process. Operating behind the slipform paver, the TC1500 applies the final surface texture and curing compound to freshly placed concrete. This step is essential for achieving proper skid resistance, surface durability, and controlled curing, ensuring the pavement meets long-term performance standards. Together, the GMCO Slipform Paver and Paving Equipment product range offers a complete, integrated solution for high-quality concrete pavement construction across projects of any scale. The GMCO S400 Multi-Purpose Slipform Paver is a versatile and reliable concrete paving machine developed by Guntert and Zimmerman for small to medium-scale infrastructure projects. Positioned as an entry-level slipform paver, the S400 delivers professional-grade performance without compromising build quality or paving accuracy. Designed for maximum flexibility, the S400 can be used across a wide range of applications, including urban streets, sloped roadways, curbs and gutters, highways, airport pavements, and even retaining walls. This adaptability makes it an ideal solution for contractors who require one machine capable of handling diverse job site conditions. A key feature of the S400 is its vari-width frame, which allows the paving width to be adjusted continuously from 2.0 to 5.3 meters without adding frame inserts. With optional extensions, the machine can pave widths of up to 7.5 meters, providing excellent versatility for changing project requirements. Powering the S400 is a fuel-efficient C4.4 diesel engine, delivering 174 horsepower. Compliant with Tier 4 final and EU Stage 5 emission standards, the engine ensures low emissions, reduced fuel consumption, and quiet operation, making it well-suited for urban environments. Advanced GMCO technologies such as Teleend for rapid width changes, AccuSteer for precise steering control, and SmartLeg for flexible leg positioning enhance maneuverability, accuracy, and productivity. Together, these features make the GMCO S400 a compact yet powerful solution for modern concrete paving projects. The Wirtgen SP1200 is a powerful large-width slipform paver designed for high-performance concrete paving on highways and airport runways. The machine is capable of paving widths from 4 to 12 meters, making it ideal for large-scale infrastructure projects that demand speed, accuracy, and consistent quality. The SP1200 can be equipped with automatic dowel bar inserters, side tie bar inserters, and trough systems, allowing it to handle a wide range of paving configurations. High-quality surface finishing is ensured by a finishing beam, super smoother, and electrically driven vibrators that provide excellent concrete compaction. Advanced features such as 3D machine control compatibility and the WITOS Fleet View telematics system enable precise guidance and real-time monitoring. In addition, Eco Mode engine management optimizes fuel efficiency while reducing noise, making the SP1200 a reliable and economical solution for modern concrete pavement construction. The Route 58 rehabilitation project in Southampton County, Virginia, introduces an innovative approach to road construction by replacing traditional asphalt overlays with hydraulic cement concrete pavement. The Virginia Department of Transportation, which has long relied on asphalt, is now testing this new alternative to reduce dependence on oil-based materials and mitigate the effects of fluctuating oil prices. In this project, a continuously reinforced concrete pavement is applied, eliminating the need for joints that typically cause the repetitive chonk-ch-ch noise of conventional concrete roads. The embedded steel reinforcement keeps cracks tightly closed, ensuring a smoother and more durable surface for motorists. The construction process involves an unbonded concrete overlay technique. First, the existing pavement is shot blasted to remove oil, dirt, and debris, creating a rough surface for better adhesion. Fresh concrete is then delivered from the batching plant and spread evenly across 2 lanes using a paving machine. Subsequent equipment ensures proper compaction and uniform thickness. Finally, a curing compound is applied, and fine grooves are raked into the surface to improve traction and safely drain water from the roadway. Advanced GPS technology precisely guides the paving machines, ensuring accurate alignment and consistent pavement thickness. This efficient method not only provides a smoother ride, but also offers VDOT engineers a cost-effective and sustainable alternative for future projects. The Virginia Center for Transportation Innovation and Research will continue to monitor the performance of this new hydraulic cement concrete pavement to evaluate its long-term success. The Power Paver's SF1700 Slipform Paver is presented as a compact and efficient solution for modern road construction projects. This machine is designed to place Portland cement concrete or asphalt concrete on roads, bridges, and other infrastructure works with high accuracy and surface quality. The SF1700 offers a minimum paving width of 2.75 meters, which can be extended up to 7.32 meters using modular extensions, making it highly adaptable to different project requirements. Thanks to its compact dimensions, the machine is ideal for tight job sites, busy urban streets, and narrow rural roads. An advanced electronic control system with 4 sensors automatically adjusts the machine height, ensuring consistent slab thickness. In addition, the SF1700 features automatic or manual steering, supported by full-range sensors, allowing precise guidance and smooth operation even in confined paving conditions. The road construction process, carried out in Bluff City by Andale Construction, follows a structured sequence focused entirely on transforming an existing dirt road into a strong and durable pavement base. The first step is offloading the slurry, where the stabilizing slurry material is delivered and prepared for application. This slurry acts as a binding agent that improves soil strength and load-bearing capacity. Before the slurry is applied, the road surface undergoes ripping. Heavy ripping equipment loosens the existing soil to the required depth, breaking up compacted layers and creating suitable conditions for effective stabilization. Once the surface is properly ripped, the next stage is injecting the slurry into the loosened material. The slurry is evenly distributed to ensure consistent treatment across the full width and depth of the roadway. After injection, the construction team proceeds with mixing the soil and slurry. Specialized mixing equipment blends the native material with the slurry until a uniform mixture is achieved. This step is essential to ensure that the stabilizing agent fully bonds with the soil particles, forming a cohesive and durable base layer. Following mixing, the treated layer is compacted using a pad-foot roller. This compaction process increases density and strength by forcing the mixed material together and eliminating voids. Once initial compaction is complete, the surface is refined through finish blading, which levels and shapes the road profile. Flat rolling is then performed to smooth the surface and achieve the final base texture. To confirm construction quality, density testing is conducted at multiple locations. These tests verify that the compacted base meets the specified density requirements. After approval, microcracking is carried out. This controlled cracking process relieves internal stresses within the stabilized layer and helps prevent uncontrolled cracking in later stages. With the base fully prepared, asphalt is paved over the stabilized surface. The asphalt layer provides structural strength and a smooth riding surface. Once asphalt paving is completed, the project moves to surface protection using HA5 high-density mineral bond. The HA5 application is completed in two stages. First, the initial HA5 coat is applied, allowing the material to penetrate the asphalt surface and bond with the pavement structure. After curing, the finishing HA5 coat is sprayed evenly. This final layer seals the surface, enhances durability, improves resistance to moisture, and extends the overall service life of the roadway. Pope Army Airfield, home to U.S. Army Airborne and Special Operations Forces, is one of the most strategic military bases in the United States. After nearly 70 years of continuous service, the airfield recently underwent a major reconstruction to support long-term operational demands. To ensure a strong and reliable foundation for the new runway, the Andale cement soil stabilization method was selected due to its proven performance and efficiency. The specially designed Andale slurry was mixed with existing soil to improve strength, stiffness, and load-bearing capacity, successfully passing rigorous U.S. Army Corps of Engineers testing requirements. This stabilized base layer significantly reduces future settlement and maintenance needs. In addition, a roller-compacted concrete drainage system was installed and densely compacted using modern rollers. This drainage layer efficiently manages surface and subsurface water, protecting the runway structure. Together, these technologies ensure the new runway will remain durable, stable, and operational for decades to come. The Gomaco GT3600 concrete curb and gutter slipform machine demonstrates outstanding performance on a challenging parking lot project in Murfreesboro, Tennessee, where England Contracting was tasked with constructing approximately 15,000 feet of concrete curb and gutter, including 43 traffic islands. What made this project particularly demanding was the tight geometry of the islands, which featured radii ranging from just 2.5 to 4 feet. Traditionally, such work would require extensive string line setup and manual staking. However, on this project, there was not a single string line in sight. Instead, England Contracting used a wireless 3D guidance system for the first time, integrating a Topcon millimeter GPS system with their new Gomaco GT3600 equipped with advanced G+ controls. After more than 20 years of working with traditional stringline methods, this represented a major shift in both workflow and productivity. The results were immediate and impressive. On the very first day, the crew completed 16 concrete islands work would normally have taken 2.5 days using conventional methods. Scott England, owner and operator of England Contracting, explained that each island would typically require around 25 stakes, followed by careful string line management and alignment. Eliminating these steps not only reduced setup time, but also removed the need for ongoing adjustments and cleanup. According to Scott, the time saved translated directly into lower labor costs and significantly reduced overtime, as the crew no longer had to spend long hours installing and removing stakes and string lines. The GT3600 used on this project features Gomaco's G+ machine control system and an auger-based concrete delivery system. Scott prefers the auger system because it keeps the machine cleaner and allows a smoother, more consistent flow of concrete, especially through tight curves and small radius islands. With years of experience operating GT3600 machines, Scott emphasized that this model remains his first choice for curb and gutter work, especially when precision and maneuverability are critical. The Topcon stringless guidance system played a key role in achieving the project's accuracy. While machine operation was relatively easy to learn, the setup process involved building digital models and loading data into the system. However, once completed, the results exceeded expectations. The GPS-based guidance was able to follow perfectly smooth arcs, something that is extremely difficult to achieve with string lines. The system allowed the machine to steer more precisely than traditional methods ever could. Topcon representatives on site explained that the millimeter GPS system combines satellite positioning for horizontal control with laser-based vertical accuracy, achieving tolerances of 2 to 3 millimeters, which is essential for high-quality concrete paving. The GT3600's all-track steering system further enhances its ability to navigate tight radii and complex curves that would be nearly impossible with conventional guidance methods. By using a shared digital model across dirt, asphalt, and concrete operations, all contractors on site worked from the same data, improving coordination and efficiency. In the end, Scott England summed up the experience simply: the new technology put the fun back into slipform paving, allowing his crew to focus on production instead of preparation. The IMB 900G New Jersey extruder is a specialized machine designed for the continuous construction of New Jersey concrete barriers. At the start of operations, the machine is positioned precisely along the work line using GPS guidance and laser alignment to ensure the barrier follows the planned route. Once aligned, the extruder begins producing the barrier by compacting high-strength concrete mix directly from the hopper into a customized forming mold. The IMB 900G's hydraulically controlled system shapes the concrete into the standard New Jersey profile with smooth, uniform surfaces. As the extruder advances slowly along the alignment, it vibrates and consolidates the concrete to eliminate voids and achieve optimal density. Operators constantly monitor the mix consistency, machine speed, and alignment to maintain quality. After extrusion, the newly formed barrier is cured in place, allowing it to gain strength quickly. The use of the IMB 900G significantly increases productivity, reduces manual formwork, and ensures consistent barrier geometry. This method offers a fast, efficient, and cost-effective solution for constructing durable concrete safety barriers on highways and large infrastructure projects. In Australia's Northern Territory, two PowerCurber 5700C Max slipform pavers are deployed to construct a 2-meter-high concrete canal wall as part of a U-shaped channel for the INPEX natural gas project. This channel forms a critical component of a regulating reservoir designed to control and manage water flow within the site's infrastructure. Working in parallel, the two machines pour concrete continuously and precisely, shaping a tall, uniform canal wall in a single operation. The PowerCurber 5700C Max is an enhanced version of the standard 5700C, specifically engineered for demanding large-scale pours. Its heavier frame and larger, longer crawlers provide exceptional stability when handling tall molds and high concrete volumes. With additional rollers in each track, the machine maintains consistent alignment throughout the pour. All-crawler steering allows accurate control along the canal's curved and straight sections, while the high-capacity hydraulic system delivers the power needed for uninterrupted concrete placement. The Max package enables construction of barriers up to 8 feet high and center pour widths of up to 12 feet, making it ideal for large canal walls like this 2-meter structure. Networked control systems further enhance precision. When integrated with modern 3D or stringless guidance technologies from Trimble, Leica, or Topcon, the pavers can automatically manage line, grade, and slope. As a result, the finished canal wall meets strict dimensional tolerances, ensuring long-term durability, hydraulic efficiency, and structural reliability under harsh Australian site conditions.